Okay, so we're gonna try doing this. I want to get up to speed on everything that happened so far, so I think I can implement all of this in one go with what I'm going to do. So okay, what I'm doing is I'm solving this problem here called word count engine, and this is an interesting problem. It requires like being able to parse a string in Python, so some very good skills. But basically the goal of this problem is you're given a document, and the document contains like sentences, right? It contains sentences. It could contain like Metamorphosis by Kafka, or I don't know. It could contain any, because that's a short story. That's why I say that, and because for some reason I'm thinking about that short story, because I don't know why. But yeah, I mean, you can contain like Metamorphosis, and what you can do with this thing is this thing will basically, what you want it to do is count the number of occurrences of those words. You want to, first off, you want to remove punctuation from your document, and you want to look at the words all with lowercase, and then you want to compare the number of occurrences, and basically you want to return the words with the number of occurrences in order of the number of occurrences and in order of their appearance in the document, and that is if there's a tie. That's how you break tie, by ordering it based off order of appearance in the document. So that's the basics. Now I've already solved this problem, and I'm going to show my code and go over it real quick how I did it. Okay, so one thing you'll notice here is that this is approach 1, and I should mention here, I'm going to analyze time complexity in a bit. So first off, my thought process was, let's convert the string to lowercase. Let's convert to a list of words and remove the punctuation, like I said before. We should see something like this, okay? Create a counter object on the list, which creates a hash map, the basics. So okay, I actually ended up not using counter object. I ended up discovering this thing that I was aware of, but I've never used it before, called an ordered dictionary. So I was thinking, why not use an ordered dictionary so that I can basically print out an order, because the order of appearance is important, or in the document, like as it says in the problem statement. Okay, so here we have number 5. Number 5 is sort the counter according to the value. Okay, obviously this changes. Then you can append. So okay, this is my initial strategy, but it changed a little bit when I was coding it. Oh, it looks like I do mention that I need an order dictionary later. Okay, so here's what I did. So I imported string, import collections. So we start by basically using this lower. This lower just converts everything in the document as a string, and it converts everything to lowercase. Then I create this dictionary here, and what I'm going to do is, in this dictionary or map, I'm going to map every punctuation in string.punctuation, which is every punctuation that we need, map it to basically an empty string. And I'm going to use this handy dandy thing that appears in Python 3 for sure. I don't know if it appears in Python 2, but we use document.makeTrans replace that. So we use our map to create this make translation, which basically creates, what make trans does is it creates an ordinal. So like right now I have a punctuation to an empty string, right? Well, instead of using punctuation to empty string, it'll convert them to the numbers, right? So it'll convert it to the Unicode numbers. So you'll now have a mapping of Unicode number to Unicode number, if that makes any sense. And then the translate is going to use that mapping of Unicode numbers, which I guess is what's important for Python, and it will use that to translate the document. So it will replace everything or translate everything. So like, it will replace the punctuation with empty strings. Cool. So then we get the word list by using our translation and using .split. This will split based off of white space. That's what it does by default, so we don't have to put anything in here. So this will split it based off the white space, and we'll get our word list, which looks like this right here. Notice the punctuation is removed here. We removed the apostrophe and everything. Okay, so then the next step is I create my answer list, because I'm going to probably need this later. So I create this count, which is going to be an order dictionary. Now I have to put stuff in the order dictionary. This is just initializing an empty order dictionary. So then I say I'm going to take the words in the word list, because in the word list, my words appear in the order of appearance, right? I'm going to have to check if W not in the count. I want to add it to the count. And the amazing thing about this is that the dictionary will be in order and everything. So perfect, we'll add it to the count. If not, and then we'll continue to the next iteration. Else, we're going to just increment the count for the whatever it was. So at the end of this, we have an ordered dictionary. And then I need to sort it though. So I'm going to take the items. Now items returns key and value. So we have a key and value, but I'm going to say, hey, sort it based off this function here. This is my key. My key function is this. What this says is, well, lambda is an anonymous function. KV is my variable, right? Why did I use KV? Well, because items gives you a tuple of key. It gives you a key value tuple. And what I'm saying is sorted based off of basically the second element in those tuples of items, which means the second element is the value, right? So that's the value is the number of occurrences. So this will sort it based off the number of occurrences, the dictionary. And I have to do reverse true because normally this will sort in ascending order. We want descending order. This sort I figured out is going to be the thing that's going to really change my time complexity. This makes time complexity O of m log m, where m, and this is something I'll mention here, m is number of distinct words in your document. Why not the total number of words in document? Well, because we're using a dictionary and it doesn't contain duplicates. So yeah, so it's just the distinct words or unique words in your document. But the runtime obviously is going to be m log m, because in Python that's the time complexity of this sorted method. So anyway, if we continue onwards, for lm and count, basically I just append these things in my count, in my order dictionary, and so this will work. And here I have two examples. Practice makes perfect. You only get perfect by practice. Just practice. Practice makes perfect. You'll get perfect by practice. Just practice. Just. Notice I have this T that's very oddly uppercase. So this has to take care of that business. Also some crazy punctuation. So I'm going to test this out, show how this works. And what am I doing? Okay, so I have to show out my secret stuff here. Yeah. Okay, so yeah, so this is what we see. We get the list, and I get the list, and it's in order. It's what we want. Okay, so now the question becomes, I realized you can optimize this. So how do I optimize it? So the challenge for me right now is, how much time am I in here? Let's see how much time I don't know how much time I'm in. I think I'm in quite a bit of time. 8 minutes in. Oh, okay. So I'm already gonna try to do this, but basically the trial here, the trial of the thing, the challenge is, how can I do this in linear time? Can I do this in O of can I do this in O of m? So maybe I can. Now if we do an O of m, we're gonna be we're gonna maybe take up some more space. So let's see how we can work this out. Alright, well, let's try to do this challenge, and hopefully it doesn't take too long. So what am I going to do? So the first thing I'm going to do is I'm going to create this thing that's keep track of the largest count, and I'm going to create this counter list. So the idea here is to make an array of arrays, where basically the index into the array is the number of occurrences, and then in that you'll have an array of the words that have that occurrence and in order that they appear in. That way all I need to return is O of m. So basically I'm just not going to have to sort it. So we're going to get rid of this sort thing. We're not going to sort this any longer. I am going to have to do largest count equals max of count W and largest count. So that's just going to make sure that we get the largest count. Why do I need the largest count? Because that's what my counter list is going to be. So counter list is going to be equal to so I'm basically just have a bunch of empty ones. I'm gonna have I need to have, if the largest count, I need to have largest count, right? I need to have it up to largest count. I think +1, yeah, because I need to include largest count. Largest count, because it starts at 0 index in Python. Okay, so this is what we'll do. So this is going to create a bunch of identical lists in here. So then the next challenge is really just filling in those lists. So so how do we fill in those lists? I mean, I guess we could just look through my counter. So I say for word in count, which is my why do I have this here? For word in count, I'm just going to, the idea would be just to go through each word in the count, which is my order dictionary, and add them to my list based off the index. So I think, will this work if I just do counter list at whatever count word, because I want to index in. Well, let's make it more clear what I'm doing. So we'll say index equals count word, or just say occurrence. Okay, so occur and dot append, and then what do I want to append to that index? I want to append a word and count and occur. Yeah, this is what I want to do. I want to create a list and a list, and then have another list. Oh gosh, that sounds bad. I think this is what I want to do. And then once it fills it in, what I would want to do. So first off, maybe I should actually check if this even did what I was expecting it to do. So we'll print this out real quick, I guess. Uh-oh. What? Saying that it's out of range? Oh. Wait, what? Does this not do what I was thinking it does? So maybe I have to say for in range. So I just want to create all those empty lists. Okay, yeah. So it does create all those empty lists. So say it creates, makes your perfect. Okay, perfect. This is what I wanted. So what I'll do is, and I have to iterate through here. So for this is taking me way too long. So I need to iterate through. So wait, I want to iterate through in reverse style. Is that right? Iterate through it in reverse. I'm trying to think. Iterating in reverse is probably work. Okay, so we'll just do for I in range of, we want our start and then our stop. So we want our start to be at largest count +1, and I want to be to stop at 0, and I want to go backwards. And for each one of these, we're going to want to do for j in range why should we just want to do for w in counter list at that I, right, at the I, and answer dot append w. I might be wrong about adding. Yeah, it works. Okay, so that was it. That's what we want to do. So yeah, I hope that was enlightening. So just work through this problem, trying to learn these techniques. This is very good practice. Why did I have to start at largest count instead of largest count +1? Probably because this is your start, and your start is exact, right? It's exact. It's inclusive. So like I don't know why I should added 1. I thought it was exclusive or something, so I thought it would start at 1 less, but it starts at that exact number, which I want, and then I want to go based off of that. So like I want to look at index 3 first, and then return the words in order, and then go to index 2 and return the words in order. And this is O of M. This is linear scan through the distinct words in this document. That is pretty good time complexity, it seems, but this is a very good problem. It's a good practice of parsing through this using translate, make, trans, and so on. So a good problem to practice.